Yeah, so ultimately what we're interested in understanding are the neural circuits underlying attention. Um, Autism, we think, is in large part a disorder of neural circuits. Ultimately, the cause of the disruption of neural circuits is partly genetic and partly environmental, but we think that the manifestation of that of the environmental and genetic causes of autism is a disruption of neural circuits. And in particular, there is some reason to believe that it's a disruption of long-range neural circuits, at least in part, between the front of the brain and the back of the brain. And those are the kinds of neural pathways that we think might be important in guiding attention. Now, one thing that pretty much anyone who's worked with autistic kids has found is that in many of them there's a disruption of auditory processing and especially of auditory attention. So one of the ongoing projects in my lab is to take mouse models that other people have developed of autism. That is, mice in which genes that we think in humans, when disrupted, cause autism. We take those genes, disrupt them in a mouse, and now we have a mouse whose neural development is perhaps perturbed in the same way that it would be perturbed in a human with autism. And then what we can ask is, what happens to the neural circuits, and how does that disruption of neural circuits affect auditory attention? And these are ongoing studies in my lab right now. We don't really have final results yet, but that's because these mice have only very recently become available. So we're very optimistic that by understanding how autism affects these long-range connections, how those long-range connections in turn affect attention, that we'll gain some insight into what's going on in humans with autism.